Good morning. Let me know how the sound is. Hold on. Good morning. Let me know how the sound is. Hold on. Good morning. All right, now tell me how the sound is. That was feedback. I sounded pretty good. Last week, I sounded horrible. I'm not sure what happened. You didn't complain initially when I was inaudible, and then I corrected the sound, but then it was just too loud. I could barely listen to those videos. You can't even turn them low enough that the sound quality doesn't bother me. Okay, good. So I have my new computer, all my new equipment. The speaker is not new, but there should be nothing wrong with the speaker. I mean the microphone. I'm not calling it a speaker, but it's behaving like a speaker. Great. Okay, so hopefully you guys can share the link in WhatsApp, and I really want students to find themselves here without me telling them every class. You know where to go. You go to the playlist, and you go to the date, and that should be good enough. Remembering, if the screen looks blurry, just to refresh your page, and if anything looks funny on your end, let me know. You can text me privately, or you can make a note in the chat publicly. So I sent the solutions I gave you solutions for most of the handouts. The only one I hadn't given you a solution for yet was the annuities exercise. It was called Annuities Review. And I gave it later. I was hoping to give it the other day, but I didn't get a chance. So I gave it this morning. And some people have already looked at it, and we will talk about those problems. So I asked you to come today with problems solved to the best of your ability so that we can review them together. Okay, there's 8 people. Let me send a reminder. Okay, I sent a message and I waited for a while, a few minutes. Do you have any questions for me right now? You should have seen that I posted the first assignment in Connect, and it's due next Thursday. Then on Friday we'll have a class, and then Saturday you have your first test. And basically it's going to be questions like the ones in the reviews. since I give you so much time, I can make them a little more challenging than the ones you have, or just different. So you have to employ critical thinking and give you some sort of a challenge, but the work should be independent. At any rate, you guys can work together right now. You can ask me for help. If you have the need for office hours, we can do that publicly or privately, online, distance, okay? And if anyone feels a need to meet in person, I'm open to that too. Okay. Very good, very good morning. All right, so these are the formulas that we've covered so far. They include the basic time value of money formula as a discounting formula and as an accumulation formula. And they are the same relationship expressed in two different ways. And I could also rewrite this formula solving for the future value, solving, so that's what I do here. I could solve for other variables as well. Okay, now if you want to do something like that and put that on your formula sheet, you're free to do that. But these formulas should get you, with your calculator, should get you to the right answer, or with some algebra. Then we studied net present value, where all cash flows were different. So I also used this in the case of not just solving for the NPV, I used it to help me solve for the value of future cash flows priced at time now 0. And these are the timelines that correspond to this formula, right? So this is the pattern of cash flows. They're all different. Well, they don't have to all be different, but they could be different. And they end at time t. And it's just really a repetition of the discounting formula from the first formula or relationship. Then we have the concept of cash flows with some sort of pattern that helps us simplify the problem into a simple formula. So if it's the case that cash flows are forever, we do not want to be punching these into our calculator in CF mode forever, or using Excel to do that. Instead, we recognize for mathematical formulas, if the cash flows are the same, well, let me do this. Okay, if the cash flows are the same, and the first one is repeated, you see, so that's always a C1, indicating that all we need is the first cash flow. The first cash flow comes one period from today, and cash flows are forever, and I is always the same. So it's always, the opportunity cost of borrowing is always I in every period, forever, even here. So then this is a simplification, and I explain why. You can look back at the video how I got that. Then I said, what if, okay, and we talked a bit about how it's possible that cash flows accruing forever actually become a single value, converge to a single value. And the explanation was that eventually, because of the time value of money from today's perspective, those cash flows in the distance become 0, really. They're not worth much, and then they become nothing, okay? So whatever's left sums, after discounting all the terms, to this amount, a single amount. Then I said, well, what if we allow the cash flows to grow? So we're going to say the cash flows grow, but not just randomly or haphazardly. They're going to grow at a steady rate, with the first cash flow one period from today, and then there's going to be growth with a growth factor, a steady growth factor of G every period. It's forever though. So the conditions were, first, level cash flows. In this case, they're not the same, but they are growing at the same rate. So they're related by a constant rate of growth. First cash flow 1 period from today, and growth in the second period. If that goes on forever, it will converge to this. This looks about the same as this. All I've done, because it's going to end up being a larger amount, I have to diminish the denominator. Okay, so the erosion factor of the dollar is offset by the fact that the cash flows grow. And this is how the formula gets adjusted. No, we're going to start the new material today. Okay? I think so. We have time. And, okay, so that's where we left off. Oh, one more thing. So then I explained, two more things. So I explained this will converge, and it will be a value, a fixed value, a total amount, a lump sum amount. It won't blow up to infinity, provided that the interest rate is greater than the growth rate. Okay, so erosion still eventually, the erosion of the future dollars occurs, and from the perspective of today, and we're adding zeros at some point, so it does actually become a value before it blows up to infinity. And that the fact that I is greater than G makes that possible. If it's not, then you get a negative here, and this whole thing is meaningless. Okay. Or if they're the same, this becomes 0 and tells you that it'll blow up. It'll become infinite. So we won't see that case. It'll always be this case, because such a deal or such a set of cash flows is not feasible or tractable. Nobody can pay an infinite amount, because theoretically that doesn't exist. Okay. Annuities then. Then we talked about what if, forget about the forever part, what if they're not forever, but they are level. So I go back to this situation where they're the level cash flows. And so that I have this part of it, but there needs to be adjustment because they're not forever. I demonstrated where this comes from. This is the adjustment factor, subtracting, after discounting, subtracting the future cash flows after this point that will not be paid or received, depending on the scenario. Okay, so that's that, and we are now here. Annuity with growth. So what is that? Let's look at our timeline. So the difference is the growth factor. So this is a mix between a fixed number of payments and steady growth. So I'm going to begin with this formula here for perpetuity with growth, you see, and then there's an adjustment factor. So what I want to do first is mention, let's talk about the pattern. Let's review this so you know when to use this. So you use this when you have a set of cash flows beginning 1 period from today with growth that's steady at a rate of G going on for T minus 1 periods, right? So that means that there's the cash flow, then there's the growth starting in the second period, and you see that's what this is telling you. So this goes from 1 to T minus 1. Now you don't have to worry too much about that unless you take more advanced courses in finance, but I want you to know these patterns well, okay? And recognize them, because what this converts into is exactly and precisely this formula. If the timeline is that of your cash flows is not exactly like this, you need to adjust this formula. So you need to know this basic formula. Well, I'm calling it basic. That's quite elaborate. We're going to practice because we're going to practice with this formula for a bit, because this formula is not programmed into your calculator. You have to enter this into your calculator. You see what I mean about having analytical skill and still using your scientific keys at the same time as being able to use the financial keys. So I make a point that with an asterisk here and here, and I say, if the formulas don't apply, in other words, if the timelines look slightly different, at all different from what I have here, you must compute the present value by using the time value of money fundamentals. That means that you will use some variation of the mixed cash flows approach, okay, to valuation. So you got to make the timeline and you got to pull them back and you got to see if there's a pattern to help you along. If not, you just got to use the mixed cash flows approach if they're different. Anyway, there's many different conditions and we'll go through some of them. All right, so let's work with this. Any questions about this formula sheet so far? So this is, for me, with this you can solve any problem. And I did discuss with you, before I continue actually, I discussed with you the idea in terms of mixed cash flows, but I could also do it here. If T cash flows beginning one period from today is valued, it would be using this formula, you would get the price here, the price or the present value of those future cash flows, right? But I could also get the price over here. I could say, what's the price here? So let's do a problem like that. I'm going to make that up because I don't actually have that in my notes right now. But I need to show you how to do that before we get to the more complicated things. How would the formula change if I wanted this instead of this? Does anybody know? I'm going to put it right on the formula sheet because I feel like there's a deficiency here unless I say this. Students take a bit to understand what to do. So how do you adjust this formula to find the future value rather than the present value? How would you do that? Juan, you wrote a question. Which question are you referring to, or which formula are you referring to? Okay, everybody else, you're going to tell me what would the formula be? How do I find this answer without having numbers, just in symbols? What would the formula be for the future value rather than the present value? So annuity with growth is G. So what it is what the situation is there's interest here and interest here and interest here, but growth starts here and growth goes on here. And all those periods, there's going to be G. Did I answer your question, or did I miss something? Excellent, Tanya. That's all we have to do. That's right. You could write in a test situation, if I asked you for the present value of this, the future value of this set of cash flows rather than the present value, all you have to do is take this amount and multiply it by an accumulation factor, right? Just like the first formula at the top. So one thing you could write is 1 plus I to the t of this. Or you can make it a little bit longer. Are you with me so far? So let's just agree on this part. Okay, Juan, I'll do that in a minute. Let me finish this and then I'll go back. I'm not too sure what your question is. Okay, let's stick with this and then I'll go to growth. So everyone agrees. So this will take the lump sum amount here, and because I've accounted for time value of money and all of that to create this value, this is the value of future cash flows of C1 for T periods, all payments at the end of the period. If I wanted to know what it accumulates to, I just take the lump sum. That will get me the answer. Another way of writing that would be expressing the entire formula. And I'm going to expect you to see that, be able to see different formulas and see how they're the same thing. I mean, the textbook has different expressions slightly than what I have. You should be able to see the similarities. Okay, so you can write it like that, or we could write it like, so some books and some professors show you foiling through or multiplying this through, and instead it ends up being this formula. Sorry. So some people might have seen this version of the formula. Okay, my goal is to help you see them all as the same thing. I'm going to get rid of these because it doesn't look good. Oh well, I hope you can see what I did there. Okay? All right, so Juan, you were asking if no one has any comments or questions about what I did. So these formulas are all the same is what I'm saying. In your calculator, all you'd have to do is rather than putting 0 in FV and asking for PV, you put 0 in PV and you ask for compute FV. That's how that works. For the annuity with growth, what I said was there's prevailing interest rate is the same throughout the period, so it's I, but the cash flows are growing at a rate G. And it turns out, because of the way the formula is, right, I cannot be equal to G. If I is equal to G, that means that the erosion factor is canceling perfectly with the growth factor. So it's like time value of money is offset perfectly by the growing cash flows. So you can't use this formula. It doesn't mean that it's wrong, and it doesn't mean that it's infinity. What you have to do is actually, and we'll do a problem like this, you have to solve it yourself by first principles, and I'll show you that there's a pattern that we can exploit there as well. I don't know, Juan, if I've answered the question, but you know what? Let's just do the problem and then just come back to me if you're still confused. All right, so let's see. Back to the notes. So here's an exercise. I'm going to start with let's see, what do I have here? Okay, starting here. So here's a problem, slide 72, of annuity with growth. So let's see. Yes, Juan. It's not, I wouldn't say exactly it's a trick, but yeah, the methodology to succeeding in this class is to understand when to apply the formulas. And hopefully you'll get the hang of that in the next week. But this material, I mean, this is the basis of finance in our calculations, so it's not like it'll be the only test where you need this skill, okay? So you're going to need this throughout the whole entire course, this skill. So if you don't have it now, you're going to have a chance to develop it. All right. So Angel can purchase an annuity to receive 30 years of supplement. Oh no, this is not. Is this the one I want? Oh yeah. Okay, sorry. Angel can purchase an annuity to receive 30 years of supplemental pension payments beginning next month. These payments will be indexed for inflation. Aha, so now you see a practical application of growth. So the person has paid into a retirement fund and they want to receive their payments from that fund. The payments will grow because there will be an estimated inflation, so the payments need to grow by 0.2% per month, just keep up with the rising prices of things. All right, so this is the G. See that? So G is 0.002, but the interest rate does everyone understand what I did there? Because these are decimals of a percent. So what does that look like? So I make a timeline, and there's the first cash flow. It grows by 0.002, so 0.002 or 0.2% per month. There are 30 years times 12, that's 360 months. And this will go, notice this exponent is one less, right? Because even though growth happens constantly, it doesn't start until the second period, so you're one off. Now, I don't expect you to make a timeline perfect, but these are important things you can be practicing to be comfortable with applying the formulas. So we have perfect alliance between, this is one period from now. It looks like it accords with my timeline on my formula sheet. So, and then growth kicks in. Okay. And then it's the same forever. I'm just putting it like that to remind you there's interest accumulating. And it's fixed. It's the same. Now, let's put this in the formula. So this is what I expect in a test situation. Oh, I'm going to describe the formula there. Skip that for now. So this is the formula I showed you that I'm going to defend or justify in a minute. And here I've applied, I've put all the values inside. So in a test situation, remember, I said I want to see this. If you write this, this gets you no points. Unless I say, write the expression for annuity with growth. Now, how do we enter this into our calculator? That is the question. I suggest, now again, I want you to be using the BA2 Plus to practice this in anticipation of writing the CFA exam. So what we have to do is start right in the middle. Start here. And I would say, 1.002 divided by 1.005 equals to the power of 360 equals. That is this piece. So once you have that, you have this part. Let's change the sign to a negative. To do that, I'm going to use the toggle key positive negative and then plus 1. Now I have the whole factor, this adjustment factor here, and say equals. So I have the whole factor. Now I have to just, I did mention before, simplify your problem. Don't put this in your calculator. Simplify that to make that 0.003. And so we multiply by 100 and divide by 0.003 and say equals. So with those steps, you should get that amount. Let me know when you get it. So it's 1.002 divided by 1.05 equals, raised to the power of 360 equals, change the sign to a negative and add 1 equals, so now you have this whole factor, then multiply by the numerator and the denominator and say equals, and you should have this. And this is the value of $100 growing at 2% for 359 periods. Very good. Okay, so you can take a screenshot. You need to practice that, and you'll have that chance with the exercises I sent. Okay, so a couple of questions for you. While some people are still solving, Okay. Right, so x squared is just like y squared. So if you use x squared, that means that this would be a 2 here. But we're not having 2, we have 360, so that's why we have to do it like this. And so x2, I'm going to say, is not the same. So if it's more general, you want to use different numbers than a power 2, you use y to the x. And this is why I take time with this, because students are not used to these symbols. But once you get it, it's useful. Okay, just a few more. And those people who've gotten already, try and answer my questions. The others who are still punching, I'll give you some time. People who have the TI-83, 84 calculator are probably going to do the long form expression. Try and do it this way as well, okay? It's good to have different techniques. When I was a student, I had the habit of solving exam questions like 2 or 3 different ways. That way I'd know I'd have the right answer. I had so much anxiety about having the right answer that I had to have different ways to get to the answer. It's the only way to check things without checking with somebody else during a test. Exactly 1. Okay, so Paula, so I'm going to demonstrate the formula next, okay, Paula? So I'll explain why that happens. So yes, it's good to notice that it's 359 here, but that's not in the formula. And I'll show you why. So this seems to be working quite well with my new computer. It's more powerful, much more powerful. The fan isn't starting, it's not making unusual noise. It's very quiet here. You just give me a couple more people getting it and then I will move on. Okay, Anthony, so you did these steps with the T84 or just with the screen? Okay, so let's see about the questions. So some of you got it. So what if, first of all, if G is greater than I, what happens if G is greater than I? Well, if G is greater than I, this will be a negative, right? But also inside here, this will also be a negative. So a negative times a negative will be a positive, and that makes sense. So it's all right for G to exceed I, remembering that it was only when it was the perpetuity that we had to worry about that happening and making the formula become undefined or infinite. You see this, because this will be, so if this is bigger than this, that will be a negative result. Now if this is bigger than this will be bigger than 1. That's what happens. So because this amount is bigger than 1, so because this amount is bigger than 1, then to the power t will be bigger than 1, and then 1 minus a number bigger than 1 will be negative. That's basically it. Everybody okay with that? So a negative times a negative will be a positive. So this is going to be okay. Right. In the perpetuity, it's not possible. Oh, okay, Anthony, you solved it your way. Just make sure you can solve it with this as well, okay? Well, in fact, I think in the TI 83, 84, 85, 89, there's so many versions, in the programmable calculator, you can probably program this formula in your calculator. Now, in a in-class situation, I wouldn't allow that. I would force you to punch it in, because that's how the CFA exam is. You'd have to do this manually. All right? So practice those things. Make sure you can do it manually. Like this. All right. So I explained, if G is greater than I, if growth exceeds the opportunity cost of borrowing and lending, this term will become a negative, that will become a negative, so the overall term will be a positive. So that's okay. That makes sense. What if G is equal to I? What happens? Right. If they're equal, they're in effect, there's no real growth happening. That's right. Because anyway, they're canceling, right? You're going to have this canceling effect of growth and the interest rate, growth of cash flows, and the erosion factor due to the time value of money. But in essence, you cannot use this formula. That's the important thing. So the result is, do not use this formula, because it's going to turn out there is an answer. There is an answer to this question. So the formula disintegrates because you have I minus G in the denominator will become 0. So this will become 0, and then this term will become 1. So in the bracket it will be 0, so you'll have an indeterminate case of 0 divided by 0. So the formula is not to be applied when I equals G. It doesn't mean that there isn't an answer though. So I'm going to give you an exercise now where I and G are the same, and we solve this in a different way, okay? So you need to remember that. So just saying that again. So if I equals G, this will be 0. And if I equals G, this will be 1 plus I over 1 plus I, which makes 1. 1 to the power of T is 1. And then 1 minus 1 is 0. So now you have 0 divided by 0, because this becomes 0. And that does not make sense, right? That's telling you that the formula breaks down in that situation. You have to have a different formula or a different approach. All right, so I'm going to move to that example, and then we'll talk about the formula and where it comes from. So here's an example of I equals G. So you're considering a deal where you will receive $100 cash flow for 4 months. So I made it a simple one. Starting next month and each month thereafter, the cash flows will grow by 1%. So we have the conditions of the formula. However, so first cash flow 1 period from now, and then they start to grow. The catch is that these are identical. So the erosion factor and the growth offset each other, and our formula does not apply. So what do we do? Well, as I mentioned, use the first principles that we learned when we learned about the discount factor and the basic time and the mixed cash flows approach. Okay, so treat these like they are just cash flows. And this amount gets discounted by 1.01, and the next amount would be 100 times 1.01, and you see what's going to happen? I have to discount it by 1.01 squared, you see? And the next one would be 100, 1.01, that's power 2, because there's 2 periods of growth, but then it gets discounted 3 periods, because it's 3 periods from now. And finally, the last one there's 3 periods of growth that have passed for the cash flow, but 4 periods of time from now. So that's discounted 1.01. Now I have to add all of these, and what do I get? How do I simplify that? Well, you guys can watch me for now, and then I'll pause if you want to make notes. So there are 2 of these, but 1 of these. So that ends up leaving you just with exactly what you had here. Is that going to happen again? Let's see. 2 of these will cancel with 3 of 2 of those, leaving 1 on the bottom. So there's a pattern here. A different pattern. And finally, 3 of these on the top will cancel with 3 of these on the bottom, leaving 1. So they all reduce to the same term for 4 periods. Okay, so from the perspective of today, the answer is just now, if you find a way, if you remember this timeline, the condition, so if it's just like a growing annuity, except that I equals G, then you can make a general formula for yourself on your formula sheet. So this is annuity with growth. And I equals G. And it fits exactly that timeline except I equals G. So you can say in general, PV0 see, do I have it on the next page? No, I didn't write it. Okay, so let me write it here. Sorry. So in general, PV0 would equal T times C1 divided by 1 plus I. If you really are craving another formula, that's what it would be. Okay, so let's see what the answer is. The answer, so I carry it out here for you. And then solve it. So yes, 396.04 is the final answer. All right, so you learned a lot. We're almost done. I want to explain this formula, so let me give you some time. Where should I stop? Okay, I'll just put the answer here, so 396.04. So this ends up being equal to 396.04. So messy. I don't know if people need a multiplication sign there. All right, any questions? I'm going to explain how we derive this formula. So I'm going to do this in the general case. This is our timeline, right? So it is the case that the first cash flow is 1 period from today, then growth kicks in, and it does continue to grow for T less 1 periods. So there's t minus 1 periods of growth, because the first one, there's no growth, right? But interest is always accumulating at the same rate. So remembering, we're going to borrow from the perpetuity formula. This is the perpetuity formula. It's in the front. But our cash flows don't go forever. They stop here. So that means we will not be getting or paying the ones after t plus 1 in the perpetuity. Or, sorry, including t plus 1. So after t. So we don't pay any of these or get any of these cash flows. So we're going to subtract off the present value of this amount. Now this is another perpetuity that starts at t. The first payment is 1 period from now. So that's the first cash flow that goes on top. And then I minus g. So this is the general formula, but applied with this first cash flow. This represents the first cash flow. That's all I need for my formula. So remembering, for a perpetuity with growth, you need the first cash flow and I minus g. That's it. And as long as I is greater than g, this is fine. In this case, my first cash flow is this whole amount. It's the first one that's coming. And then I just throw under I minus g. So you see, Paolo was asking, why is it not t minus 1? It's because I'm starting, these are the ones I'm not going to pay. I'm going to subtract off. That starts t growth periods away. And so what I do is I discount this amount. That's what this comes from. So this is, and again, I'm not going to ask you to prove this, but you need this technique. You need to learn this technique in the next few weeks. So I'm going to discount that. That's the discounting term for t periods. And then I'm going to subtract that from the overall perpetuity. So that's the next step. So I subtract, I call this A, I call this B, and I subtract. That's what I do here. B from A. I do some algebra, I collect my terms, and this is my formula. All right, so that's why that ends up being a T. So the reason why it works out is because this is common to both pieces, right? So I factor that out, that's here, and it leaves a 1 in place of what was here, minus what's left over here. This piece, which was the growing t periods of growth, and the discounting piece, t periods of discounting. And that is that. So that formula in the box corresponds to this. So review that with the video. Get used to those steps. We're going to practice this when we we're going to practice this kinds of algebra when we solve the annuity problems in a little bit. The annuity review that I gave you. All right, so that's annuity with growth. Should we take a 5-minute break? Let's take 5 minutes before I get on to the next, and you can ask me questions. Did I miss anything? Let me make sure I did everything. So 5 minutes. All right, I'm back. No questions, looks like. And we are here. So this is another applied exercise. We talked about someone saving money through what a formal, they purchase an annuity. They actually purchased a commitment for the person who sold them the contract to pay them. So that was the exercise here. In retirement, they should be paid and compensated for inflation with $100 a month. Now, obviously, this is not their whole pension, right? This is just some supplemental. It says supplemental. This is something additional. So they pay, in this exercise on page 72, they pay something at time zero. The individual Angel pays something at time zero to receive $100 for 30 years every month for 30 years. So it's a little bit extra on top of whatever else, what other pension money or savings the person has. And you're told that this is $100, but it's adjusted for this inflation with a commitment of 0.2% per month. Okay, so let's see. I didn't mention. So we went through the trouble to find out what that would be. So that is worth. That turns out to be worth $21,970. So Angel pays $21,970.77 for this contract. In so doing, he has adjusted, or he has hedged against inflation, right? And he's captured the opportunity cost of 5.5% per month. So I'm going to ask you something. This is just supplemental, so this is just the extra $100 a month. What if you wanted to figure out how much you need to save today in order to earn a defined benefit in the future? So we have here a pension case. In this case, I tell you what amount we're going to deposit. And with that defined deposit, so this is what I'm depositing, $3,000 per year. Now I'm on the yearly basis for 30 years into a fund earning. This is the interest rate per year, with the first payment 1 period from now. Then, when this ends, I retire and I begin earning a payment, a set payment for the next 20 years. What should that payment be? So we have two problems in one, and this is where students, they understand how to do one problem at a time, but we're going to combine two applications, two formulas in one problem, maybe three. Got it? So this is the cash flow in to a fund that accumulates to time 30. So that we could figure out the future value at time 30. So now we'll know what it's accumulated to here. And then how much can be withdrawn each year for 50 years. So think about this, $3,000 per year. Maybe it's a lot for a student, but okay, $3,000 per year is like is 12% per year. So that's approximately, on average, over many years, the return on the stock market. With all the ups and downs, it turns out, and we're going to talk about this in the class, that it turns out on average to be about 12% a year, more like 11. So that's not completely unrealistic. Obviously, it seems like a distant reality, and with the volatility that we see in the markets right now. But on average, it looks like the stock market goes up. And if you calculate an average overall, a regular arithmetic average is about 11 to 12% on average. All right, so let's figure out what that payment could possibly be. So my approach is going to be to figure out the future value and then use that, remembering every single point in time is both has a perspective looking back. So these amounts accumulate to time 30. Also looking forward, this amount can be dispersed out into the future. So I'm going to equate. I'm going to say whatever I find out the future value of those 30 cash flows accumulating at 12% that's going to also be the present value at time 30. So I'm going to use this expression, even though maybe it's confusing. Right now, I'm going to use the fact that this has two perspectives. So then, I am going to solve this with my calculator after writing out the formula. This is the formula for the this is the present value of $3,000 for 30 years. It's a lot, right? It's almost $1 million. So $3,000 for 30 years in present value terms is about $1 million. This is the present value at time 30, let's be clear. So wait, did I miss a page? Let me see. Is there a page down here? Can't keep track of that. Okay, so let's start here. So at time 0, the present value of $3,000 at time 0 is $24,165.55. If you punch this in your calculator in the way that we know how, with 30 years, interest is 12, the present value is what we want, so we leave that empty. 3,000 is the payment, and we put 0 into future value and compute present value. This is what you get. But that amount is the same as, remember, we can move this amount that we calculate here and we can push it forward to here by simply accumulating it. Okay, so the lump sum from the perspective in 30 years, this amount accumulates to be almost $1 million. That's the number we were looking at before. So you have almost $1 million accumulated in a pot, or I do. That's what my story line was. So I'm going to have this amount accumulated here from which I can withdraw. Now, meanwhile, as I'm withdrawing, it's still accumulating interest, and all that is accounted for with this formula, okay? This formula here is setting that amount, that lump sum, that pot of money that continues to accumulate at the interest rate 12%. You see? I'm going to figure out what the payment can be to exhaust that amount in 20 years. So those are the two formulas I need. Well, there's three formulas, 3 steps, I guess. First you calculate the present value, then you convert it into the future value, or you can see that as one formula. Oh, it stopped writing. Let me see if I can refresh this. Let me see if I can refresh. Okay, what I'm gonna do is just, thank you for letting me know. Okay, let me see. I'll repeat what I said. So what do I do? Oh, I have to do this. Better? Okay, so from the top. So from the top here. Okay. So let me make sure about my internet, because the Wi-Fi connects the iPad to the, yeah, it's okay. Looks like it's working now. Okay, so again, what we're talking about is creating a fund for ourselves to withdraw money in the future. And the question is, how big a payment can I withdraw in the future if I deposit $3,000 a year into a fund earning 12%? So the approach to figuring this out is to figure out what the future value of those cash flows are, and then see that as a fund, right, that I can withdraw from. So whatever happened here, it is collapsed into just this figure here. So I want to figure that out, and then I want to treat that as the present value of those future cash flows. So I'm going to first calculate the future value of these cash flows and then use it as the present value. So I express this to remind you that at each point in time you could look back or you could look forward depending on the problem. So I can equate these two to solve this problem. Future value at 30 and present value at 30. So the way that I do that is, first, I figure out the present value because I have that formula for determining what $3,000 for 30 years at 12% will be. But I really want the accumulated amount. So I'm going to accumulate that for 30 years to get this, almost $1 million. And then I'm going to use that amount as though it's the fund here. This represents the fund, and I'm going to call it PV30. And I'm going to figure out now as though I want to know the payment of this annuity, right? So this is they're just annuities, 2 annuities and an accumulation factor to solve this. So those 3 formulas should get me the answer. On our calculator, the steps are, I'm going to make it really fast, okay? So It turns out that the answer to this question, if you have almost $1 million in the bank that continues to earn interest at 12% while you withdraw some amounts, you're going to be able to take out about $100,000 a year, which sounds just fine right now. Notice I didn't index for inflation or anything like that. All I did was use the payment formula, the regular annuity formula. And it's about $100,000 a year for 20 years. So how do I get this number? Okay, step 1. Enter the regular annuity with the $3,000 payment to figure out not the present value, but the future value amount. That's what I want. And store that into your calculator. You're going to store it because then in the second part, you're going to use this as the present value by recalling and putting it into the present value for 20 years at 12% to find out this payment. So why don't you practice that and let me know where you get stuck. Very good, Julian. Got it. How about the rest of you? Do you need me to punch it in? I think you guys can do this with the instructions as they are. We've done enough now. Just don't lose sight of what exactly you're doing. So you're solving. This is the annuity, regular annuity. The catch is that you want to calculate the future value rather than the present value. And then store, recall, and this one, this is another annuity. And using this from the previous question and now asking for the payment. So you would have to deposit about $3,000 to earn 12%. Earning 12%, you would have about $100,000 a year pension. It's not so bad, depending on what inflation ends up being. But the central banks work to reduce inflation or keep it under control. So this is the simplest version of this problem, the pension problem. I could add in indexing as well in another exercise. Okay, 26 watching. How many of you got it? At least 10 of you should get it. Let me know you got it before I continue. Yeah, my video is really lagging behind, so make sure you refresh often. I don't know why it's doing that. I can see that it's lagging. So if I put something here, I'll see how long it takes. Okay, so it's about 10 seconds lag. That's not bad. So Paula's saying if you enter the payment in negative here, this will go in as a positive, and then you'll get a negative payment. Sorry. Wait, what did I say? So if this goes in negative as a payment, then your stored value will be a positive. That will go as a positive, and then this will come out as a negative. So yeah, my signs are wrong. What you could do, I should make a note, maybe change that, is anyway, if you do it like this, this will be a negative. I don't know why I didn't change it. Okay. Okay, it should be a negative. Okay, so a lot of people got it. Good. So final statement before we do the problem, some of the exercises I gave you, is regarding timelines and identifying how many periods have transpired. Are we all on the same page? So people who still have to work on the other problem, you're going to have time with the video you can watch and correct or see what you did wrong and let me know if you're still not sure. So I want you to be able to tell the difference between periods of interest and payments. Remembering these intervals are intervals of interest, but payments occur at the end of a period unless otherwise stated. So if I asked you, how many periods of growth are possible between the end of the 18th period and the end of the 55th? How would you figure that out most efficiently? I suggest, if you ever get confused about this, whether it's 55 minus 18 or not, to figure out the intervals between 18 and 55, what is the right approach? Well, just look at your fingers. If you want to figure out the gaps between your fingers, so let me draw fingers, you're going to see. Oh, it's not so bad. Yeah. Okay, so if you're going to draw fingers and if you look at your fingers, your hand, and you want the intervals between your fingers, and you label your hand, your fingers on your hand, 1, 2, 3, 4, and 5. How many intervals are there between, or spaces? There's 1, 2, 3, and 4. How would I get that? I get that by doing a calculation of last, should be last minus first. The last number, which is 5, minus the first number, which is 1, will give me 4 spaces. So that is the approach to going between the fingers. So this is correct. The last interval minus the first one will give me the number, the last end, or the end of the total period. So the last one minus the first one indicated would tell me the answer. So I'm telling you about your hand because you can just use it without having to check the notes. Just remember, you need to remember this tip. So it's 55 minus 18. There are potentially, there's 37 periods of interest and potentially 37 periods of growth. That's a different question than asking you how many payments there are between 18 and 55 inclusive. Similarly, if I asked you how many fingers you have on your hand, you would take the last one minus the first one, but that would just give you 4, and you know you have 5 fingers, so you need to know the trick. So first of all, just to wrap up the first part, is the number of intervals is equal to the end of the last minus the end of the first, or if it's between beginnings of periods, so if you're talking about something like paying rent or a lease or a loan, you would go from end to end, or in that other case, beginning of the last to the beginning of the first. You'll understand if you see problems like this, what I'm getting at, I guess. So just as I did, the intervals between here that you can't see very well, you can easily see them on your hand. If you want the intervals between your fingers, there's only 4. So you did 5 minus 1, and here you do 55 minus 18. This is different than the number of payments. The number of payments, if I said how many payments between the 18th and 55th inclusive, look at your fingers. That's not going to be as nice. Okay. Like that. So again, 1, 2, 3, 4, 5. There's 5 fingers. How do you get that mathematically? You take last minus first. And you add back 1, okay? So 5 minus 1 plus 1 will give you 5 fingers. Just a quick tool to remember. And in this case, it's going to be 55 minus 18 plus 1. So there it is. 38. I could have said that the same question would have been, how many payments are there between the beginning of the 19th, because 18 at the end is also the beginning of the 19th, and the end of the 55th. That would be the same question, okay? So you can see the ways that you can call it tricking you or testing you in your understanding. All right, so we have the 2 rules. The one I told you, for number of intervals, and you have this rule for number of payments. And you might see that that comes in handy when you can't see your full timeline. So I use the dots a lot. You'll see those a lot, and this will help you understand what's behind them. All right. Any questions? So intervals are different than tick marks. One, it's not between the periods. I actually want to know the number of payments. So I want to know what's here. In other words, I want to know how many lines there are, just like I would like to know how many fingers there are. So I have to add 1 back. Because when I take 5 minus 1, I lose the 1. So I have to add it back to pick up all the fingers. Okay. All right, so that's a tip for you. Maybe you're not going to see that much in this class, but it becomes, this is useful in finance to know this. All right. Okay, so the next topic is going to be interest rate conversions, and I've already sent some material on that, but let's focus right now on the homework exercises I gave you, and I will take any questions you have about the different reviews. Some of you might not have had a chance to look at the answers or even solve them. You need to solve them. The test is next week. You should solve all of these this week and then use the clave that I gave you to review your answers. I've given you an idea of what kind of value questions like this have in terms of worth for the test, so you can practice. In this exercise, this is review 1. I have just a basic time value of money. I do NPV. I do like a mixed cash flow sort of thing, or you can see this as 2 annuities, a mortgage problem where a mortgage is like a loan, then do another one with stocks, and so perpetuities and growing perpetuities. Those are the exercises there. Any questions about any of those on review 1? Or first review? So what I wanted to work with was these annuity problems and solving them as I ask you to as annuities, okay? So some students might have just used the NPV to solve these, but that's not the idea. I want you to practice working with annuities. It's going to be very important that you develop that skill because we're going to talk about dividends for valuing stock, and dividends paid to stockholders will be assumed to grow at a constant rate for a little while, and then it'll change, the rate will change, and we have to be able to work with annuities and perpetuities in a sophisticated way. So you need to practice. Ariana, the exam is on Saturday. On Friday, we're going to have a class. All right. So, any questions about solving annuities? So let's see. I will give you, so people have already done this. This shouldn't be a big deal. Just tell me, can you solve for that? Do you get this answer using the annuity keys on your calculator? So let's just do this in the calculator, then we'll write the formula. Doing this a little bit backwards, but I want you to become efficient in entering these. This is an annuity because you receive 1,000 for 5 years, starting 4 years from today. Okay, that's just a little bit of a catch that we have to adjust for. And we'll talk about that. So, can you get this? So if you're to do this on your calculator, no one's saying anything. I hope you're punching away. So you're going to put in your calculator 5 periods at 8% PV is what we want. And you're going to say the payment is 1,000, which is a negative. Receive, okay, positive. And then that's going to be payment. And 0 into FV, so compute. And the PV that you get from this, what period of time will it be in? It's not going to be this answer. Hello?
Hi.
Oh, my angel, how are you?
Dad,
Sweetie,
you keep asking a little cuckoo.
what?
You keep asking a little cuckoo.
Okay, listen, Alba, I'm going to call you back in a few hours, okay? Because my students are on the computer. I'm talking to them. I'll call you right back, okay?
Okay.
Okay, I love you. Bye. Okay, so let's see. Shall I draw this? Or maybe you're watching the clave now. So, so 4 years, starting 4 years from today, $1,000 is received. So 1, 2, 3, 4. That's how it works. So 0, 1. So you have to practice making these timelines while you're learning. So 4 years from today, $1,000 begins. And that happens for 5 years. This is kind of messy. All right. If I punch this into my calculator, remember the valuation is one period before it starts. So that puts my valuation at time 3. So you would write on a test that this is $1,000 at 8% for 5 periods. And your calculator would give you that answer for punching this in. What you get is like 3,992.710037 ... right? I'm showing you the parts you have to write for the test. This will get you no points. But obviously that's what you have to enter, key into your calculator. So you need to write this for points. And then the adjustment. Because this is not the value today. Because I want you to find the value at time 0. So what you need to do is see this as a lump sum now and discount for 1, 2, 3 periods back. And that will give you the answer. I could call this PV or FV, and you see that I'm just using the basic time value of money formula. So over here, what you'll do is you will store this just so you don't lose it, because you don't want to lose the decimal places. In case you mess up too. So then you want to divide that by this amount, or you want to do, make this FV so this is like part 1, this is part 2. Wait, let me put these things in. So it's going to be 3 years now. I'm going to run out of space. It'll be 3 years at 8%. And you want the present value. There are no payments. We're just going to do a basic time value of money problem right now. And what I'm going to tell the calculator is that the future value is in my stored key, and ask to compute present value. That will give me the answer. Or just punch it in. You can take this and then just divide it by 1.08 in your calculator. You would have to put brackets. So I want you to practice that together if you don't know how to do that. The TI-84 calculator, the periods per year and C per year, I can't remember if that's right, Tanya, you did well. Diego, I can't remember if C per year is the frequency. Someone will have to tell you. I can't recall. I bought a TI-84 to help students, and I actually have some notes for it. But I haven't looked at them in a while. See if you can get the same answer as me playing around with it, Diego. So your final answer should be this one here. Oops. Should be this value here. So if you're just sitting there watching me and thinking you're going to review this later, there is no later. You need to start reviewing now and trying these exercises immediately because the week's going to go very quickly. You only have really this weekend to concentrate. And I know it's Valentine's weekend and I just know how things go. So dedicate yourself today and get through these notes. And what I teach next class is also going to be on the test. It's not going to be hard. It shouldn't be hard, but you should be prepared for the new material. Just basic problems on the new material. Nothing that you can't handle. Okay, Diego figured it out. Good. Okay, so who got this? And who still has questions? So for the test, I want this done, and then your final answer. And this looks very messy what I just did. All right, let me erase this. So I did that thing again where I relate FV and PV3, right? It looks like the pension problem. So the final answer is going to be rounded to 2 decimal places because we operate and function in dollars. That's my final answer. And I will box this off and then circle my final answer in a separate color so you can see it. And that is the value at time 0. All right, so when you write your test, if you're getting confounded, I mean, these are meant to help you. All the notation is meant to help you. If it's hindering you, if it's creating problems for you, then just don't use it. Just draw a timeline and tell me where you are, okay? And that'll be fine. So the better you present, the clearer you present your answer, the easier it is for the grader to give you points. I won't be grading these as it's just too much time for me to grade, but I do want you to have the opportunity of getting part marks. I don't want to give you multiple choice tests, so that's why I'm going to use my grader to grade. If I tell you to solve a problem as an annuity, you have to solve it as an annuity or you get no points. So if you think you're going to get away with putting this into a NPV formula, I'll give you a 0 if I asked you for the annuity. Okay? So you have to follow the instructions. Okay, yeah, so Diego, the C by Y is not changing yet. We're going to deal with that with interest rate conversions. But I'm going to try and avoid them altogether, changing that C by Y figure. Or key. Okay, can I move to the next one? Again, this is two annuities. So I call it the 2 annuity cash flow case. And starting 1 year from now, we will receive $2,000 for each of the next 3 years. So I'm going to draw this. Oh my goodness. Remember my line, my ruler that I have. It's so nice. I don't know, did I get to show you this yet? I discovered the ruler. And I should bring that back. There's my ruler. No, where'd it go? There it is. Bring it down, and I can do tick marks. And I want to make so It's going to start but I don't know why I can't do that. Okay. I guess I can't. Off ruler. So now it's 0, 1, 2. So I put the numbers up here. Starting 1 year from now, we will receive $2,000 for each of the next 3 years. And then $3,000 per year for additional 2 years. Oh, I made it too much. $3,000 and $3,000. I can erase the rest, right? I got carried away. I could have used more space. Okay. Well, that's really messy, isn't it? Let's make it nicer. Oh, I didn't want to do that. All right, I'm making a mess here. Okay, back to work. So anyway, it's 2,000 here and 2,000 here, and then 3,000, 3,000, and 3,000. I could just put K, right? I could also just put 2K, 3K like that. Oh no, I ungrouped everything. All right, this is not turning out so pretty. Okay, so I want 2 annuities. I gotta make this on another page. It became such a mess. Goodness. But I got a nice line. Some of you will think, oh, I'm just going to use the net present value, and this is going to be easy with mixed cash flows. But that's not what I wanted. I'm asking you to solve for, the 2 annuity case. So we're going to have 1 annuity here. I'm going to call it A. And it's going to be 1 period from today is 2,000, and the interest rate, oh, I gotta go back, it's at 8% still, 10%. And it's 10%, so 0.1. And then 1 minus 1 over 1.1. And there's going to be 2 of those. And at time 3, oh, not time 3. So I'm going to leave it like that. So then at time 3 is the first cash flow. But for this part that I'm going to call part I'm going to call this part A. I'm going to call this part B. Where does part B begin? So if I want the annuity, so if I was to, for the second part, part B, if I was to do 3 in N and 10 in interest and 3,000 into payment, and I put 0 into FV, and I asked to compute PV, where would that value be? What time? We're receiving, so these are all positives. I did it backwards? Okay, let's do that. That's okay, I'm gonna add one more year. Is it that way? For each of the next 3 years. My goodness. So that's gonna be there. That'll fix it. What else do I have to change? So that's gonna be 2, and this will be 3. 2, no, that's done. So 3 and 2, right? So this will be a 3 then. And this will be 2. Okay, so there's 3 of these. So that's 3 annuity with 3, and then there's these 2. So my question is, where do I put this amount when I get it out of my calculator? So if you want to see what you entered in your calculator in the TVM keys, you just hit compute and then compute N, compute I by Y. You can see your entries. Compute payment, etc. So the answer is, for this amount, is 5,206. I'm out of a space, aren't I? $5,000. And I'm writing all these decimals so you remember to keep them. So store this in 1 or in 2. I'll say store it in 2 because I want to store the other one in 1. Now, where is that going to be? Where do I put that on my timeline? Oh my goodness. Wow, how do I turn that off? Oh, I have to turn all my sounds off. Oh my goodness. Oh, I can't figure this out right now. Oh my goodness, it's so loud. Okay. All right. So I still don't get I didn't get an answer. So 1 year after the $3,000 here would put me at year 3. Okay. So what's the formula for that? We're going to put that formula in. Let's put the formula there. So that's going to be the 3,000 for 2 years. And it's going to be at year, I'm going to move the subscripts up. I mean, you have the clave, so you see the answer. But let's put it up here because now I gotta say this one is 0, but this one is time 3. 1 year before the first cash flow for the second annuity. Okay, so this is in storage 2, and it's equal to 5,206,61157. And then this one, let's get this value. So this is going to be just 3 in N. Interest is the same. And I tell it that it's a $2,000 payment. And this amount is 4,000. Oh, I have to fix my A and B at the top. Right? My messy illustrations, sorry about that. That's why I have all my notes typed. To avoid you having just messy notes to refer to. Okay, so then this is going to be 4,973,703,982. And this one I'm going to store in 1. So this is 1, store 2. So what's the next step? So I did step 1, I did step A and step B. So step 1 and 2 are done. Then what? Am I done? So what I want to do is take the A part and add it to the B part, but the B needs to be at time 0. Right now it's at time 3. So what I need to do is I need to discount this back, right? Before I do that step. So this has to go back to time. It has to go back to time 0, discounted back. So in the formula, notice, this is 3, I have to go back 3, so these cancel to make 0, right? So this subscript and this superscript and this subscript cancel to bring me back to time 0. I could call that FV, I could call that PV. You should know what I mean in this case. So FV3 and PV3 are the same thing. So since that was stored in number 2, I can recall it. Now you're probably saying, why are you doing all of this? You don't need to do all this. These are simple exercises to get you to practice for the more complex ones that are coming. Okay? So you're going to say, you could do in your calculator, so this is the other trick I have, right? 1.1 y to the x 3 equals, and then flip it. That will be easy to multiply to recall 2. So I'm getting this value and I'm multiplying it by this. That's one way to do it, or you can just do recall 2 divide with brackets. Okay. So what is that? If I take the value I do recommend writing all this stuff down until you're good at this. You know, how are you going to remember where you put things in a complex problem? These are going to come out as negatives, so you should just change the signs to make them positives, right, when you get them, to avoid confusion. Just a recommendation. So what I'm doing is I'm taking this amount, this 5,200, and I stored it in 1, but now I need to discount it back. So I'm going to find out what it's worth at time 0. And let me know if you need me to show you on my calculator, if you know what you're doing by now. So I get what should I do with that? I'm going to store that as well. I'm going to store that as 3. So all I am going to do in the end, what I'm going to finish with is I'm going to add recall 1 plus recall 2. Because that will be, not 2, 3, sorry. That will be this one and this one. That should work. All right, I'm going to give you some time to make sure you can do that. You can catch up. Oh, sorry about that. No questions, no comments? So quiet. I did it again, sorry. I keep pulling out, oh my goodness. I'm trying to set things up here. So no comments. So, what you're supposed to be doing is following the steps I've outlined. But if you just want the answer, that's something else. But I'm trying to show you how to use 2 annuities at the same time. All right? So in the end, you're adding what I've said here, recall 1 from the stored value for these cash flows, the present value of these cash flows, And then you're going to add it to the present value of these cash flows that are stored in number 3. So you're adding like 5 and 4,000 to get the final answer of 8,885.51. That's what you should have. So your final answer should be 8,885.51. So I want you to do it that way because we're going to do much more complex problems. Okay, so you need to be able to show me what you're doing. The clave that I sent has it written a little more clearly, of course. Oh, my pages are out of order. I don't know what just happened. So there you go. So that I was just describing the steps for this. The last problem is for you to practice. I'm not going to help you with that one. This is to practice annuity due, all right? And that's to practice annuity due. So you can practice the 3 methods. Remember, we talked about that already, so you can practice doing that. And other than that, what I want to talk about right now is the discounting and inflation. Document 1.6. Before we go, I want to talk about this. And leave this with you for the week and have you just practice with these exercises. Oh, I do want to mention something else before we go. If you don't have any questions, I'm going to continue with this. So this is also an annuity problem, but you'll notice this is for growing annuities. And I'm introducing the reality of inflation now. I'm going to distinguish between nominal rates, which I will also refer to as discount rates. Okay, because we're dealing with present value in finance, this implicit interest rate is also seen as a discount rate when you're computing present values. So that's the nominal discount rate. There's also going to be expected inflation in this problem. And then I mentioned something about real cash flows. So how do you tease apart all this? What's the relationship between nominal rates, real rates, inflation rates, and cash flows? There's 2 relationships. So let's begin with the relationship between interest rates. So you all took economics. What is the relationship between nominal and real interest rates? So far, everything we've talked about has been treated as nominal rates. Okay, so all the rates, I haven't said anything about real interest. I didn't mention inflation and indexing, but I've just said, I've just been working with an interest rate or return on investment or price of borrowing and lending or opportunity costs. I've used all these terms, but the idea is that they're nominal rates. So does anybody know the relationship between them? So if I wrote RN for nominal and RR for real, what is their relationship? You guys can Google it. You can try. I shouldn't even. No, you should know this. Well, I want the relationship, the mathematical relationship. They're rates. They're related. How are they related? And then I'll talk about interpreting. So some people have learned that the real rate, the actual cost of borrowing and lending, plus inflation is the nominal rate of interest. Okay, and this is true. This is what you learn in economics. When the inflation is small. So this represents inflation. It's a symbol we use. So inflation is the effect of prices rising. Prices rise. We can, without getting into why, this happens over time. So it could have cost a few $100s 50 years ago to go to university, and now it costs thousands. So prices go up. So this is what you learn about economics, but this is just an approximate. So this is approximately true. In fact, the direct relationship is a factor relationship. Inflation acts like a growth factor on the real interest rate, giving us the nominal interest rate. So if you knew inflation, you could determine what the real rate of interest is by deflating the nominal rate of interest. You see? Okay, so what does this mean? This is the best example to describe, so this makes more sense. All right. In particular, what I want to do is if I wanted to find the rate, I would have to take off this principal amount, right? But okay, I'll just leave it like that for now. Okay, so let's see. What am I talking about? Here we have a problem where just like the other problems, we're going to see the 8% is the nominal discount rate. So we're going to treat this as we have in the past. This is like our interest rate. And inflation is expected, we're told, to be 2%. What is the present value of 6 payment annuity of $1,000 in real cash flow? So this really captures what we mean by real in this exercise. I'll show you by using a timeline to illustrate. Juan, we are in unprecedented times, I have to say. I honestly, I don't see how they can do much of what they're doing right now, but somehow because of the petrodollar, the United States manages to be able to keep ahead of inflation, exporting inflation, they say. So, what can I say? I don't know what's going to happen. As long as the United States can continue to do that, America can keep up, and they'll have to just transfer payments to us in Puerto Rico because we don't have the ability to for fiat money to be printed here. Anyway, so without going into all of that, let's look at this exercise. I'm going to use my arrow again. Not my ruler again. It's red. And what I'm going to do is chart out here. I'm going to call these real cash flow. So this is the example. Okay, so 6 payment annuity of $1,000 in real cash flows. So I'm going to use green for my cash flow. So this is 1,000. So I'm going to just do 1K, right? Takes less space. 1K. So these are 1,000s. Or maybe that's confusing. I'll just use 1,000. 1,000, 1,000, 1,000. So what this means, $1,000 real cash flows aren't different dollar bills, okay? What it represents is that you are being, in this situation, to receive $1,000 in real cash flow means that whatever you could buy now with $1,000, so let's say you bought a tablet, okay? You bought a tablet today. This means $1,000 real cash flow allows you to budget because it says you're going to be able to buy a laptop next year and the following year, or the equivalent of a laptop in value by the end of every year for the next 6 years. That's what real amounts do. So it captures purchasing power. But I want to convert that into nominal in the second part, where I ask you to do things differently. So in this problem, I'm saying use the regular annuity formula, this timeline, and compute the present value of the cash flows. It turns out, so we have 2 formulas and a rule that you need to learn. The first formula is this relationship I just talked about, that 1 plus the nominal rate is equal to 1 plus the real rate with a growth factor. That's one relationship. And this is called the Fisher equation, and I'm going to spell it wrong for some reason. I spell it wrong lately. The Fisher relationship. And we're going to talk more about this in a later unit, but right now you need to know that. You also need to know or something else. Let me say, we also need to know how to convert from real to nominal cash flows. I'll just put it in here so they're side by side. I'll move it later. So what would be the nominal equivalent of these amounts? In other words, how much money will you need to have in your pocket or in your bank account to be able to buy a laptop in a world with 2% inflation? Move this down. Okay. Yes, Diego, look up the petrodollar, American. Yeah, because United States forces countries to trade oil in the Middle East in American dollars, effectively protecting the United States from catastrophic inflation. Okay, so, all right, help me here. So I said there's two formulas and something I have to tell you, a principle, before we go in 2 minutes. Well, I have 6 minutes. So how much will I need in year one? Oops, what just happened? How much do I need in year one to be able to buy a tablet at the end of year one if there's inflation of 2%? We're going to use the 2% as the growth rate that our cash flows would experience, right? If we're getting 1,000 in real cash flow, that means in our pocket, in our bank account, we should see 1,000 times 1.02. I'm going to do that a little bit more over here. And then in the second year, I need a little bit more, 1.02 squared, to be able to buy the tablet. And I'm going to need 1,000, 1.02 cubed, to be able to buy a tablet, and so on. What I'm going to do is make this a little bit bigger so it can fit. A little bit bigger. Oh, then this happens to me. You see? Not going to be able to go in. Oops. Okay. All right. Get it? So this is going to be real, but in reality, this is what I need in my bank account. So this is just the concept of real with a base year. So it's real with base year times 0. I should add that. It doesn't say it here, but okay, so everything's related to how much $1,000 buys me times 0. And this would be the nominal cash flows. Now, the trick is, there's two things I just showed you. One is that there's a relationship between real and nominal cash flows. And I'm going to write it down in a second. And I've shown you that we have to do these things. We have to quantify real cash flows separately than we would quantify nominal cash flows. To determine the present value of real cash flows, you must use the real rate. To quantify or determine the present value of the nominal cash flows, you must use the nominal rate. Okay? And it turns out the real cash flows discounted with the real rate should give you the same result of the nominal cash flows with the nominal rate. And that result, I should give you the value of that. So whatever you get here, you should get here. All right? So we have one relationship that I told you. That's the relationship between the rates. You have the relationship between the cash flows over time. So the cash flows at any point in time, for them to be nominal, I'm just going to make a formula out of what I just did here below, is equal to the cash flow that are real adjusted for inflation for however many years past. So that's not really clear because my notation is not so clear, but so I'm going to send you the clave for this sheet. Well, I want you to try it first. It's more meaningful. And you're going to apply these three concepts: the relationship between nominal and real rates, the relationship between nominal and real cash flows, and this fact that to value cash flows that are real, you have to use a real rate, and to evaluate cash flows that are nominal, you have to use the nominal rate, and they should be the same. Let me just get the value, and then you guys can practice that. And then when we get back next week, because now time is up, we're gonna work on the second part, but you should also prepare that. So the answer that you should get Did anybody get anything? No one did it yet? So it should be for both A and B. $4,935.55. Now this is using all those things that I showed you and not rounding when you solve for the real rate using this expression. No rounding, okay? No rounding to get this answer. So what I'm going to have to say to you, because you have to leave or you're already gone, and maybe checking back if you had to go, you're checking back with this video. I'm going to make the test mostly everything up to here, including this, and then some of the things I teach on Friday, but very basic stuff I teach on Friday, okay? So Friday material will be on the test on Saturday. And that's the way it's going to go, all right? So you have all the materials you need. I will send you... Oh, I'm not going to send you this clave because I want to talk about this. I will send you this clave maybe on Wednesday. Okay, I'll send you this clave on Wednesday. So make sure you prepare it. And any other clave that I missed, I'm going to send on Wednesday. For you, you need to realize, obviously I cannot give you problems exactly like this because I've solved them on the videos and you could just watch the videos and copy them out for your answers. So I have to give you different questions. So it will appear a little challenging, but just you need to know these well, okay? You need to know how to solve these problems well. Now, if you didn't understand anything about this discounting and inflation stuff, that's fine. Just rewatch the videos and ask me any questions to help you get through it. Okay? But work with it, and I'm sure you're going to be fine. Let me know if you have any questions. I'll stay on for another 5 minutes if you do. So anybody that missed the video, you guys can watch it later. Not to worry. Just going to confirm what's the last set of notes. I guess 1.7. So Friday we're going to talk about interest rate conversions, and I'm going to teach you some of the basics. Okay? Bye. Have a good weekend.